Code, programming, software development, recursion, object-oriented programming, design patterns, concurrency, Big O notation, IDEs, APIs, Agile, Scrum, Git, Go, Rust, Python, Pandas, C, C++, C#. Why are there so many Cs? Kotlin, Scala, Perl, Ruby, Java, and JavaScript. Not the same thing. PHP, HTML, CSS, MATLAB, AI, machine learning, neural networks, precision trees, graph theory, semantic clustering, Q-learning, backpropagation, Stack Overflow. How are we feeling? A little overwhelmed? Programmers and computer scientists definitely live up to the nickname coder. And for good reason. I mean, there's a lot of new terms to learn. This field is infamous for being so dense and technical that a significant portion of the population seems to have convinced themselves that programming just isn't compatible with their brains. And people who have are simply smarter than the rest of us. Culturally, we revere technically minded people, and their hard intelligence is placed on a pedestal above lowly soft skills like critical thinking or empathy or the ability to effectively communicate with other human beings. Do you feel curious about learning to code? Do you think of yourself as someone who could? And what about the other people in your life? Come on, I mean, aren't some of them just not that kind of person? The weirdest thing about this whole programming is hard to learn perception is that there's a good chance it's not even true at all. If that's true, why do we still treat it like it is? Firstly, let's address why it seems so difficult. One reason might be that it's pretty hard to fake. The code compiles or it doesn't. The tests pass or they don't. Efficiency is no longer an abstract idea, it's in Big O notation. And unlike writing, which one might marginally improve through enjoyable activities like reading fiction, with programming it's really just about doing it. Practicing enough that any edge cases don't stump you, so the basic stuff is easy and your brain is free to think about the big picture. Programming is about patterns, and once you've seen them enough, it becomes intuitive, like speaking or typing or decoding speech, despite all of these acts consisting of very complicated individual operation. Of course, learning these patterns is no walk in the park. There's a learning curve, which requires you to be comfortable with a lot of complexity and confusion in the beginning. There's new notations, there's code. Worst of all, there's all kinds of weird stuff like IDEs and Git that you need to wade through just to get to a place where you can write code that actually does something for somebody. And despite all the pretty symbols, it can be a rough subject for visual learners. Computer science does not have the best track record in terms of its graphic design, and the visualizations, if they are provided, leave something to be desired. And finally, even once you know it, it's easy to get rusty, just like any language. Depending on how in practice I am, I probably only retain around 20% of the information I've ever learned about programming. Knowledge, like life, is fleeting. So I guess given all of this, it's no wonder why people think it's hard, but does it need to be? All of the challenges I just listed are real, but not insurmountable, and not even unique to programming. Overcoming them basically involves changing a few key things about how we think about learning to program. Number one, crush the idea of inherent talent as a prerequisite for learning something. Recently, I had coffee with someone I met here at the JetBrains office, and we were talking about why we became interested in programming in the first place. I didn't grow up with an especially high regard for my math and technical skills. I did okay in those classes, but I usually had more fun in English or theater or art or something I seemingly had more inherent talent in. My colleague had felt the same initially, but she told me about this one teacher that she'd had who was really good at seeing potential in all her students, no matter their ability in the moment. Often, knowingly or unknowingly, teachers devote most of their energy into educating students who already demonstrate some skill in a subject, encouraging them, challenging them, providing extra help, and getting their ability as high as it can go. But the best teachers are the ones who can see potential for anyone to learn anything at any point in their lives. This is really important because a lot of the time what we seem to be inherently good at is a product of our informal and previous educations as well as our cultural perception of who typically succeeds in a field. If I grew up being exposed to a lot more logic and math puzzles, then there's a pretty good chance I'd be more inherently good at math. If I recognize myself in the visible programmers in media, I might be more inherently motivated to believe in my own success when the projects got difficult. Going into my own education, I knew both of my older brothers had learned programming in college, so honestly, I figured it couldn't be that hard. Sorry, bros. There is no critical window of development after which you cannot learn to program well. You're not going to be coding in a bad accent. When boot camps and courses say that no prior experience is needed, they mean it. Number 2, if statements are not an alien science. Can you understand this snippet of code? What about this one? If so, congratulations, you possess the basic abstract reasoning skills you'll need to be able to learn to program. This stuff isn't rocket science, it's a language. The basic grammar isn't very hard to pick up, and the rest is just a matter of diligent practice. Even object-oriented programming and inheritance are not unique to coding, nor especially difficult to grasp. These concepts are not inhumanly complicated, and I actually believe that one of the reasons that they're perceived to be is because of the lack of good materials written by people with good empathy and communication skills. Do you know who often doesn't see themselves as the kind of person who can code? People with good empathy and communication skills. And I'm gonna need to apologize to like 80% of the office for that joke. Please, I'm begging you, learn it and prove me wrong. And in case you're looking for a suggestion on how to get started, may I recommend the courses that you can find on this funky little website, academy.jetbrains.com. Number 3, read the numbers. When I was learning an instrument for the first time, I didn't like the effort that went into learning to play from sheet music rather than from memory. It was slow and annoying, and it didn't sound as good, so I would spend as little time and effort as possible reading the music. I wasn't building the synaptic translations between the notes on the page and the muscles in my fingers. Instead, I would just try to memorize it as quickly as possible so I could play it without looking at it anymore. This is a bad strategy, and it applies equally to deciphering the challenging notation and interfaces you'll encounter when learning to program. When presented with a page like this, or this, you might be tempted to skip over the hard parts, but if you learn anything from me, learn from my mistakes. Read the notation. Number 4, don't learn to program. People always say we should learn to program, but learn to program is in practice a bad goal. It's vague, all-encompassing, and hard to see the boundaries of. Have you learned to program after passing an introductory course? After a whole degree? Will always be parts of programming that you don't know and don't need to know. So rather than defining your goal as the skill in and of itself, it's better to set your goal as the tangible thing you need that skill for. In the beginning, you won't know how to create your amazing cross-platform app or website or game. Sometimes you just have to solve FizzBuzz because it's good for you and builds character. And I have good news that climbing the programming learning curve is a little more forgiving than something like playing the violin. Because even basic skills are useful and fun, and you definitely don't need to work in tech to benefit from them, especially now, given recent advances. If you finish a beginner programming course from one of many providers, say, gosh, I don't know, something random like JetBrains Academy, and get to know your way around a professional IDE and get a feel for debugging, you'll be in great shape. Even if you don't end up as a programmer, the process of improving your computational thinking by using code and algorithm to solve problems can help you scale other learning curves when learning things like animation or video editing or design software. It's a pretty good and universal skill to have. So, is it actually hard? Well, is learning hard? Yes, ideally. This is why teachers don't want their students to write their essays with ChatGPT. A healthy amount of difficulty is necessary for learning. But is programming more difficult than something like psychology or Spanish or public speaking? No, absolutely not. Stay tuned for my next video, AI and the Future of Programming, where I'll investigate whether learning any of this even matters at all. If you can't wait, check out our videos on Git. I made a short one which explains the technical details visually, and a long one which goes into the history of why it was made, which I swear is more interesting than it sounds. If you're particularly inspired, you could even close YouTube and start learning to program, which, as I've established, is not that hard. Links to the JetBrains Academy Learning Center with free IDEs and courses are in the description. That's all for this one. I hope you liked it, and good luck with your learning.